Hey, welcome back. I am Tammy and I do math for coffee, and we are going to go over how to handle exponents in division problems. Let's start with one that just has numbers. We have 5 to the 6th power divided by 5 to the 2nd power. There's all kinds of exponent shortcuts, but they're not actually the math. Let me show you the math one time, and then we're going to use the shortcut after that. 5 to the 6th power is 5 times itself 6 times, and that's being divided by 5 times itself 2 times. When it's written out like this, you can cancel factors. So one of the 5s is going to cancel a 5 on the bottom, another 5 will cancel the second one. What's left, that's a 1, and what's left in the top are 4 5s. And so this works out to be 5 raised to the 4th power. That's the math. The shortcut for that is noticing the exponents. If you have 6 on the top and an exponent of 2 on the bottom, that's going to be 5 to the 6 minus 2, which equals 5 to the 4th. That's the shortcut. You subtract the exponents. If you ever get stuck and can't remember the shortcut, just always revert back to doing the math. The shortcuts are not the math. X to the 5th divided by x cubed. Well, that's going to be x to the 5 minus 3, which is x squared. X to the 6th times y to the 9th divided by x to the 2nd, y to the 5th. All right, for these, you treat each variable separately. So starting with the x's, we're going to do x to the 6 minus 2 times y to the 9 minus 5. Do the subtraction. Our final answer is x to the 4th, y to the 4th. We have m to the negative 3rd divided by m to the negative 5th. There's actually 2 ways to do this, or at least 2 ways I thought of. Starting out with just using the shortcut, we have m to the negative 3 minus negative 5. It's important that you're careful with those double negatives in the middle because that makes a big difference to the answer. We end up with m to the negative 3 plus 5, which equals m squared. A different person might look at this a little differently and remember how to handle negative exponents. If you want to review the negative exponent rules, I'll put a link up in the corner here for you. M to the negative 3 in the numerator can be rewritten as a fraction 1 over m to the 3rd power. M to the negative 5 will do the same thing, and the denominator becomes 1 over m to the 5th. Now, when you are dividing fractions, you skip, flip, multiply. 1 over m to the 3rd power times, flip the bottom one over, m to the 5th over 1. Multiply straight across, m to the 5th over m cubed. That is going to be m to the 5 minus 3, and that equals m squared. You choose the method that you like. You may have even come up with another idea on how to do a problem like this. Some will be longer than others. Just keep grinding it out until you get to the end. This one's going to be a little intimidating looking, not even going to lie. There's a couple ways to go about this one. When you have a power raised to a power, like the whole thing is being raised to an exponent of negative 3, you can apply that negative 3 first to everything that's on the inside if that's what you'd like to do. So it becomes 8 to the negative 3, x to the 4 times negative 3, so it'd be x to the negative 12. Down below you have 5 to the negative 3, and then x to the 5 times negative 3, which would be negative 15th. All those negative exponents get turned into fractions. 1 over 8 cubed is really 1 over 512 because 8 times 8 times 8 is 512 times 1 over x to the 12th power. All of that is being divided by 1 over 5 cubed. 5 times 5 times 5 is 125 times 1 over x to the 15th. Let's do a couple steps in one. The numerator, I'm going to multiply those and then just recopy it. We end up with 1 over 512 times x to the 12th. If you multiply the denominator fractions out, you get a 1 on the top. Because we're doing division, I know this thing on the bottom ends up getting flipped over. So I'm going to put the 125 x to the 15th on the top and the 1 on the bottom. Multiply straight across, we get 125 x to the 15th over 512 x to the 12th. If 125 and 512 could be simplified at all, I would, but there's nothing that goes into both of those. So it's 125 125 over 512 times x to the 15 minus 12. Our final answer is 125 over 512 x cubed. I'm going to do this problem a different way because you may prefer this method opposed to the one I just did. With this one, I'm not going to bring the -3 in and put it on everything. I'm going to simplify what's inside the parentheses first as much as I can. We should get the same answer. So 8/5 times x to the 4 minus 5, and we end up with 8/5 x to the -1. All of that is being raised to the -3rd power. I can't do anything more on the inside of the parentheses, so now I'm going to bring in that outside power. That's going to be 8/5 raised to the -1/3. When you're raising a power to a power, you multiply them, so it's going to be x to the -1 times -3. Applying that power on the fraction, we get 8 to the -3rd over 5 to the -3rd, and then x is going to end up just being to the 3rd power because -1 times -3 is +3. Using properties of negative exponents, I know they flip around, so the 5 to the 3rd goes up to the top, 8 to the 3rd goes down on the bottom, times x cubed, and we end up with 125 over 512 times x cubed. Same answer, just done a different way. Pause the video and try this one. When you start the video again, I'm going to put the solution up so you can check your work. Hey, how did you do on that? Did you start it a different way? Tell me down below in the comments. What came up in this video a lot was negative exponents working with fractions in parentheses. Here's a video that goes into that a little bit more. And here's the whole playlist on exponents. Thanks for watching. I'll see you next time.